Hi guys, my name is Aman and I've been doing a project on the development of an Android app for receiving analog signals as part of my summer internship program in 2014 under Design and Innovation Hub at IIT BHU. As a part of the project, I was supposed to interface Arduino, Beagle Blue Black and Raspberry Pi with the Android app to receive Android signals and plot its graph so that it's visually appealing. So now I'll be explaining you the Android side code so that you can easily get started with my Android application to receive analog signal from any source. So let's begin. So what I'll be doing is I'll be writing the code and side by side I'll be writing the comments to explain you what the code is required for. I hope you guys could easily catch up with this. So let's begin. So for the first thing, we'll just write the constants. The first constant would be like specifying the pin to specifying the pin for receiving the Android signal. And so I'll be using the analog pin A0. So okay, so here we go, and analog input pin. So this would basically specify the pin from which we'll be receiving our analog signal. Next thing is we have to initialize the sensor value, in which it's a variable in which we will be storing our sensor data. Okay, so we'll just initialize it with 0. Okay, the next thing we'll do is just specify an integer for the for loop, because we'll be using a loop to send data, as a app sends data for exactly 12 seconds, so we'll be needing it. For now you won't understand why are we using it, but as I write the code further, it would become pretty clear. So next I'm initializing the conditional boolean data, so that our Arduino knows when to send the data, because it's completely unnecessary to send data all the time. It would be a waste of time and energy. Okay, so this is the condition we'll be using after we get an acknowledgement that the connection has been established between the Bluetooth module and the Bluetooth module that is connected to the Arduino and the Arduino with the Android smartphone. Okay, so as a RX the Bluetooth module I am using is a serial port. It uses a serial port profile. So basically it would be having like 5 pins. The first would be like a key pin, the next would be the VCC, a ground, and the RX-TX. So as you all of may know, or most of you might not be knowing also, the Arduino has one serial port already specified, that are the pin 0 and pin 1 that are assigned to RX-TX, right? But we won't be using them, as it's used for programming the Arduino and also receiving the serial data from the serial console. So I'll be using an library called software serial that's included in the Arduino package. So we'll just import it. So basically I am using is this library just for our convenience while we program and reprogram our Arduino, in case it doesn't interfere with our programming code while we are burning our code to Arduino, and also while we want some debug messages on our serial command line or serial console. That's why basically I'm using it. So I'm calling my so I'm using the software serial library. So what I need to do is I need to initialize an object of the type software serial, and I'll call it my serial. So the constructor of the software serial takes two pins as input. So I'll be giving the 10 and 11 as the input pins. So the 10 would be the RX pin and the 11 would be the TX pin specifically. So in case you might feel lost somewhere, you can follow my comments to see what the command means. So the basic idea was basically to explain you the comments and explain you the working of the code. Otherwise the code is supplied with my project package. Okay, I'm not so good at typing. Please, if you could ignore that. Okay, now as of you, many of you must be knowing that the structure of how Arduino works. So we'll need to just set up the things, initialize things for the first time, and that are written in the void setup of the Arduino command pattern or architecture. So what I will be doing right now is initializing the serial command for debug messages, or in case we are having any trouble with the programming. Well, I don't believe you will be having any problem, because the code I am writing is already quite well debugged and used properly. But still, I'm just telling how have I proceeded with this project, and for the debugging process of this project, this was quite an important step. Okay, so please don't mind my spelling mistakes. So we'll be initializing this at the baud rate of 9600. There's no specific reason why I'm using this baud rate, but this is the most generic one you will find out. So what I'm doing is just initializing the serial. So now, as I already told, I am using a library implementation, that's software serial, just to keep things more easier for us while we are programming and writing the program again and again. So we'll now need to set up the object which I initialized my serial. We'll also need to initialize that. So with me dictating it might sound boring, but I can't really do anything. This is my first video I've been doing. Okay, so we are done with the void setup. Now we'll be going to the void loop. I believe you might be knowing that this is the loop which is continuously looping around once the setup is called. So in this while loop, what we'll be doing is, like, we'll be capturing the data from the analog pin. We'll be taking it, the data value. We'll be sending it to. We'll be converting it, that integer value, to a character, and will be then as a string or character, and then we'll be broadcasting it to the my serial port, so that the Bluetooth module connected with the Arduino can send it to the Bluetooth of the Android smartphone, which would receive and store it in a file, then which then can be plotted on a graph. So that's basically what my project is about. So, well, my project is all about developing the Android app, but still I just need to explain you the basics of interfacing the Arduino and other development boards, so that you can get started with my project without any prior knowledge or what to say, wasting time on things which are not really necessary for going and improving my project or taking it a bit to a further level. So what I'm doing now is I've just took the value of my serial, reading from it. If there is a serial input available on my serial, it would be read and stored in the in-char. Now as you can see, the in-char is defined as an int type. So let's just carry forward. I don't think you need an explanation here. Now if send ADC, now this is where I put the condition that we should send the data, sensor data or not. Okay, so why I have done this is just to not to waste the Android's Arduino's power and time by continuously sending the data when it's not required by the Android application. What this complete setup does is, like, whenever the Android application and tries to connect to the Bluetooth module, and when it's successfully connected after pairing and all, that interface can be explained with the Android app. After that has been done, the Android app sends a character A, which is having an ASCII character value of 65. You must be knowing that. So it basically it would send a 65. Basically it would be sending a character A. If I will typecast that into int, it would give me 65. That's the value of ASCII value of that character. So if I receive that A character, that means I have established a successful connection, and I can now be sending the data to the Android app. So before sending the data, I need to acknowledge that the connection has been established, so that the app also knows that the connection is proper and it's been working. So what I will do is, first of all, I will send a ASCII value of B, so that the app knows. Hey guys, sorry for the interruption. This is really not a sound place to do a recording. My hostel. Okay, so well, now I believe I've been explaining you the structure and architecture of my code, Android side code, pretty well. I have been told most of the things about it. Now I think it would be better if I write the code and then just dictate you what the particular instruction or code means, so that you can get a better idea of how the things are working. So I'll just pause the video and write the code first beforehand, so that I can comment out the things and explain you what the code does. Okay, so I'll be pausing the video now. Okay, so here's the next bunch of code, and what it does is, basically it's dependent on the send ADC boolean we defined in the initial coding. Okay, so what it does is basically if send EDC is assigned true, then it would read the value and it would write the value on the channel, RF channel that has been established between the Bluetooth module and the Android app. So but as for now, when the loops run for the first time, the send EDC value would be false, as we have initialized it as false. So this won't be true. So what is basically this code would do if in the further code we will write and assign it as true, is the send EDC true. This would basically do is whenever the send EDC is true, it would read the data and supply that data to the serial port, and so that it could be broadcasted to the Android device. This is what it does. Okay, so I'll just write the commenting so that you can have a better understanding of what it does. Okay, and so this is just this instruction used to read from the analog pin, and the next instruction, that is myserial.println, this is used to broadcast the value to the Bluetooth channel that's been established between the Bluetooth module and the Android phone. Okay, and as you can see, there's another line of code, that is I++. Do you remember that we initialized a character integer I is equals to 1 in the beginning? What it's being used to do right here is we have to send the data exactly for 12 seconds. That's what my app is designed for. The app would receive the data exactly for 12 seconds, so that we can have an understanding of whatever the signal is. It's not too less, it's not too much, so that it doesn't take too much of memory in the smartphone, but it has to be some significant value. So I have arbitrarily chosen 12 seconds as my value for the recording of signal. So in our case, we'll be taking the value of I from 1 to 1200. Now why are we taking the value of I from 1 to 200 is 1200 is I mean 1 to 1200. Why are we taking it for the values from 1 to 200 is that I have included a delay of 10 milliseconds in this while loop, this void loop. So this loop would approximately will be running for 10 milliseconds. Now if I run this send data for 1200 times, that would mean 12,000 milliseconds, right? So that would account for 12 seconds. So that's what I'm supposed to do, send data for exactly 12 seconds. So now basically after 12 seconds it should automatically stop the sending the data, right? So what I will do now, if I is greater than equal to 1200, I equal to 1, I am reinitializing the value of I and setting the send ADC to equal to false. Now as you can see, we haven't really put the value of send ADC as true anywhere in this code for now, but as I told you that the architecture of this code works on the basis that there should be an acknowledgement between the devices, the Bluetooth module and the Android phone, that there is a Bluetooth connection. Until unless there is a clear pathway between the two, there won't be the data sending and receiving. In fact, there won't be even the reading of analog value from the analog source, because that would be really of no use, right? So let me just pause the video for now and just write the more code, and so that I could explain you in a better way. So I'll be just pausing the video. Okay, the next chunk of code now we are with is basically for acknowledging the data transmission between the two devices. Now what it does is, if the in character value, that's what value we have read from the myserial, is equal to 65, that is the ASCII character value of A. So when the app is connected and we start recording the signal from the app, the first thing that app does is, after the connection is successful connection has been established between the app and the Bluetooth module, is it sends A, the character capital A, and the capital character A is represented by here by this 65, right? So when the in character is 65, and that is we have received A, and send ADC is not true. That's what basically would be for the first time, and my serial dot print B would do is like send an acknowledgement that yes, I have received A, and now I'll be sending the data, so please be ready for it. So for the telling the app that I'm the Arduino is ready for sending the analog signal, we are sending it a B. That is the acknowledgement for it, right? So this is the acknowledgement data. Sorry for my spellings. I'm really not good at English, right? Okay, and we'll now set the send ADC data true. So now what it would do, whenever the loop starts again, if send ADC, that is right here, this thing would read the sensor value from the analog read, that from the analog in pin, and analog pin in what we have set is, there is A0. It would, okay, I've made a mistake here, right? Okay, see, I have not verified the sketch for now till now, because there are some code that's why I'm sorry, that's why I'm not completing. So as I complete the code, I will do it now. What we have to do is, this is the case when we have received A and send ADC is false. Now what with the case when now we have said send ADC true? So it won't be sending the B character, right? So it would just be sending the ADC value, and if this is not the case, it would check for if in car is equal to 65, 67, right? 67 is stands for C, stands for the letter C, right? This. So when the app wants us to stop the data transmission, it would send a C, right? And for the acknowledgement of it, we'll be sending B. So what this chunk of code would do is basically, right, and okay, I think I've took a lot of time explaining you guys this simple thing, but still I was supposed to explain this all, and I think I made it pretty clear for you. So the last thing we are supposed to do, as I told you, that we'll have to send the data for exactly 12 seconds. That would mean that 12,000 milliseconds. So we need to give this loop a delay of total of 10, so that in each loop it has a time period of exactly 10 milliseconds, and so that it would the loop would run for 1200 times, and that would cost for account for 12 seconds, right? So just a second, I need to, okay, so we are adding now delay 10 milliseconds, right? Okay, so for the comments of it, we'll just wait for 10 seconds for sync app data transmission. And also note that we can't do this. Also please note that this tells us the sampling rate. Now what sampling rate would mean, like for between which interval we are taking the read values. As for example, we are having an analog data at the receiving end, right? And we can only transmit digital data on a Bluetooth transmission, right? So we need to change that ADC value, that analog value, to digital value, right? But we can do this only for discrete time interval, right? So we'll be doing it for every 10 milliseconds. So this also specifies the sampling rate of our data. Okay, so I think this is it for now. I hope I have made myself pretty clear. Then we can even check if we have made any mistake. Oh, we have made a mistake. So okay, so can you guys just tell this again? Okay, so here's the mistake. I've done a typo. Software figure when creating a library. Just again. Okay, here's another typo. Sorry for the spelling mistakes. I already told you. And this is my first time, so I believe you can ignore this. Okay, let's read it. And I believe we're good to go. Thank you for watching. Peace.